Hello everyone, welcome to my channel Security Beast. So this is the fourth video of the same series exploiting stack challenges on the ARM platform. So we have solved till from stack 0 to stack 3, and now today we are going to take a look at stack 4 challenge. So let's take a look at stack 4. So here we can see what is the difference between in previous challenge and this challenge is like in previous challenge we have a function called fp to call, and in this challenge we don't have any function to call. So if you see we have to win this challenge we have to call the function win, where it will say code flow successfully changed, and here in integer main we can see the integer argc and argb. The character buffer is 64 and it is just calling the gets buffer. So to exploit this kind of challenges, what we have to do is we have to control the return address. So once this flow of execution is done, then the return address get called for exit, and that we need to control in this challenge. Okay, so let's see how can we do it. So let's get started. So we have here the challenges. Okay, and what we'll do is like we'll run the GDB on the stack 4. Okay, now let's see what are the functions available in this. Here we can see the get. So if we give the address of the win function to gets function, then I think it is possible to call the win function at the flow when the flow ends. Okay, so let's see what main says. So like this as main. So here we can see it's pushing, and then add, subtract, move, then branch link. Here the get function is getting called. So at this point maybe we should give our inputs, and here the stack pointer and r1, and it is adding the 4 byte. Okay, so let me let me break the program here when it is moving r3 to r0. Oops, this as main, and let's take this address, or let's take a get address. Okay, now run the program. Okay, next instruction, it is taking the values, and you see, let me just put the zoom out. So we can see here still we are not still our payload is not reached to this return address. So let's see what happened. Our goal is that our payload should reach to the return address, then we can, you see, now our payload has reached to the return address. Now we need to identify like 1A, 2A, 3A. So 3A reaches. So I think last 3A managed to reach till this address. Okay, because there is one 0x40 which is unidentified. So let's create a pattern of let's say length 80 or some. So like and length 80, and just to find out what at what place it goes into the return pointer. So here we can see we got this value. Now let's try to match the pattern with MSR. So we are saying, so it says that the pattern is match, the pattern exactly match at 68. So we know the after 68 or at 68, we have to give the win function address, so that the next return address will get called from next return address which will get called is from the of the win function. So let's just try our old trick like a Python address, and yeah, first we have to get the address of win function. What is the exact address of win function? So let's get it first and grep win. So this is the same address if you remember from previous. It was just save and see. Now we have to give the 4C. So if we search for 7C from our previous payload, now we know we have to give the padding till 68, as at 68 we want to call the address, and we just have to change from 7 to 4C to execute our function. And now we, instead of stack 3, we are passing this value to stack 4. Okay, I hope this exploit should work when we run it. Let's see, cross the finger. Yeah, here we go. So the code flow has been successfully changed. That means we solved the challenge by passing this value to this.